All right, friends, for our first chapter in the second semester, we're going to be moving on for a second, just for a quick chapter on quadrilaterals. But before we move on to quadrilaterals, we're going to go over two more rules that you probably already know, but we need to explicitly go over about triangles. So this is a quick lesson on kind of summing up everything we've learned so far about triangles, and then we'll move on to quadrilaterals. Okay. You probably have noticed before, but we're explicitly naming it a rule now. But in any triangle, the longest side of that triangle is going to be opposite the largest angle, and the shortest side is opposite the smallest angle. So here's what I mean. If you're looking at this triangle right here, which side is the longest side? Well, it's really easy to see that this side right here is the longest side, okay? And what this rule is basically saying that the longest side of any triangle is always going to be across from the largest angle. So since this is the longest side, the angle that is opposite of that side, which is that angle, will be the largest angle. And that should make sense to you. Basically, what this is saying is that there's a direct relationship between the size of an angle, how big that angle is, and how long the side opposite that angle is, okay? Which kind of makes sense. And the opposite is true, or I guess not the opposite, but following. The smallest side, which is this is the same triangle over here, this looks like it's the smallest side, will always be across from the smallest angle, okay? So clearly, this side looks like it's the shortest, and the angle that is opposite of that is going to be the smallest angle, okay? So if we're looking at an explicit example, here what we have is a triangle. Hang on, I'm going to move this up a little bit. A triangle with side lengths of 9, 8, and 7. We can't know exactly what the angles are going to be, but what we will know is which angle will be the biggest and which one will be the smallest. So if we're looking at this triangle, since 9 is the longest side, the angle opposite of that will be the biggest. So the measure of angle C is the largest angle. And because this angle right here, this side right here, side AC, is the shortest, the angle opposite that, which is angle B, will be the smallest angle in this triangle. Okay, so that is a rule that you can now use in any argument or any time that you need it, and something that you can assume to be true. The formal rules for that are stated here. Those are called Theorem 5.10 and 5.11. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. That's a lot of words. Here's what it's saying. Since 11 is bigger than 7, the angle that is opposite 11, which is the measure of angle Q in this picture, is going to be bigger than the angle that's opposite the shorter side. That's all that rule is saying. That the measure of angle Q is going to be bigger than the measure of angle S, and that should kind of make sense to you. Well, the other direction is true as well. If we have two angles right here, we got two angles, then we can know for certain that because the measure of angle Q is bigger than the measure of angle S, then the side opposite angle Q, which is RS, is going to be greater than the side opposite angle S, which is QR. And remember, if I write 2 points like this without the segment on top, then what that means is the distance between R and S. So what we're saying here is the distance between points R and S is greater than the distance between points Q and R. Okay, so just as a refresher. So you can use these two rules, Theorem 5.10, Theorem 5.11. A lot of you have probably already been using them intuitively in your thinking, but that's the official rule there. So let's continue right along. One more quick thing on triangles is the triangle inequality. That's Theorem 5.13. Here's what the triangle inequality states. The triangle inequality states that the sums of the lengths of any two sides of a triangle is greater than the length of the third side. Probably takes a couple of read-throughs to really understand what that's saying. So what I want you to do is actually want you to pause the video for a second, read this through, and try to really understand what it's saying before moving on. Okay, so go ahead and do that. So what this theorem is saying is that if I add together the lengths of any two sides of this triangle right here, then the sum of those two sides will always be greater than the third side. So let's do that. Let's do that for this triangle. Here's what this is saying. We're going to call these sides RQ in red. We'll do RS is blue. Okay, and QS is black. Okay, and when I write these down, we're going to be talking about lengths. Okay, so we write lengths without the segment. This means the length of RQ. This means the segment RQ. Okay, right there. That means segment. That means length. So when we're talking about lengths, we're just going to write it this way. So what this theorem is saying is that in order for a triangle to be a triangle, all three of these statements must be true. RQ plus RS, adding those two together, has to be greater than QS. All right? And in this triangle, we don't really need to write any others because very clearly QS plus QR is going to be greater than this one just because QS itself is greater than RS. So we'll take the two shortest sides, which are RQ and RS, and those added together must be QS. And here's the thing. If these statements are not true, if this is not true, then guess what? It is not a triangle. It would look like this instead. Something like that. Where actually, in this specific example, I'll draw it specific to this example instead of in general, it would look something like this. Where it actually, the side lengths would not be long enough to make a triangle. Okay, so this must be true of every single triangle. So if there's a question that gives you lengths and says, there's a triangle with side lengths of 5, 4, and 3. Is this a triangle? What it's asking you to do is to add up all two sides and make sure that they're always greater than the third side. So in this specific example, let's do that. 3 plus 4, since those are the two shorter sides, have to be greater than 5. 4 plus 3 is 7. 7 is greater than 5. So can this be a triangle? Yes, it can. That, in fact, is a triangle. Okay? So the triangle inequality states that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Okay? So that is it. What you have in your notes is you should have 2 more slides that have example problems that I want you to go ahead and work on now. So do those example problems. Come show me your solutions when you're done. I will check them. And I'm actually going to have you do this problem right here as well. So you don't have to do this one. Only do the bottom one of this. So do this problem here on the bottom and then do this slide here. Come show me the solution to your work, and when you're done, you can move on.